Hello and welcome back to For Knowledge once again. In this session, we are going to discuss about differentiation using first principle. Let me write it down. Now the question which comes at first is what is differentiation? Differentiation is very simple if you say it in English. Okay? It is nothing but changing the function with change in x. Okay, that means the change in the value of y with respect to the change in x. Fine. So let us consider initially the value of x was x1. After some time the value of x is x2. Fine. Now when the x was x1, then the value of y was suppose y1, and when x is x2, then the value of y is y2. This is the scenario. Fine. And suppose x2 minus x1, that is change in x, is very small. Change in x is very small. This is the setup. Okay, this is the setup. That means the x is changing from x1 to x2, and at the same time the y is changing from y1 to y2. Then what is the change in the function with respect to change in x? So the change in function is y2 minus y1, and change in x means x2 minus x1. Okay, their ratio. That's how we calculate. So the change in the function, that means y2 minus y1 with change in x, that is x2 minus x1. Now let y equal to fx. That means so y2 will become f of x2, and y1 is now f of x1. What is y1? y1 means y calculated at x1. y1 means y calculated at x1. Okay, so y1 means f of x1, that is when the value of x is x1, then the functional value is y1, and when the value of x is x2, then the functional value is y2, y calculated at x2. Okay, so f of x2 minus f of x1 is nothing but y2 minus y1 divided by x2 minus x1. Okay, now from this we can write x2 is x1 plus h. We can write x2 as x1 plus h. So this is f of x1 plus h minus f of x1 divided by x2 minus x1 is already h. Fine. So this is the reconstructed formula for changing y by changing x. This one is the new formula. Okay, not a new formula, rather new look for the old formula. Fine. And now what was told? It was given that the h is very small. If we about to calculate this value, then we have to incorporate the limiting condition for h. we have to incorporate the limiting condition for h. So limit h tends to 0, f of x1 plus h minus f of x1 divided by h. This is the derivative, this is the formula for derivative of this y with respect to x when x is x1. Okay, what is this? This is the derivative of y, or this is the differentiation of y with respect to this x when the value of x is x1. Okay, so for every x, if we generalize the formula, for every x, if we generalize the formula, then the formula becomes limit h tends to 0, f of, now no x1, now we don't use any x1, we use only x because this is the generalization, f of x plus h minus fx by h. This is the differentiation of y with respect to x, and this is the differentiation using the first principle. This is the formula for first principle. So first principle is nothing but it is coming from the definition of differentiation. It is nothing but the definition of differentiation. Change in y, that means change in the functional value, divided by change in x. This h means x plus h, that is the new value, minus x, that is the old value. X plus h minus x. So change in x, and in the numerator change in y when the change is very small. That is why the limiting condition. Got it? So this is the first principle for differentiation. Now, if this is clear, let's move on to some one or two examples. Fine? I am keeping the formula here. Let us take this example. Differentiate y equal to sin x using first principle. That is the first question. Okay. So what do? We first consider y is fx, which is nothing but sin x. Y is fx, which is nothing but sin x. Now we have to calculate dy upon dx. Use the formula. Limit h tends to 0, f of x plus h minus fx by h. Now fx was sin x. What is f of x plus h? Limit h tends to 0. Fx is sin x. So this input goes to here. So if in the input it is given that we have to put x plus h, then in the argument of sin we put sin of x plus h minus f of x means already sin x divided by h. This is the formula we have applied. Fine. Now how to proceed? Look, in the numerator there is a very known form which is used in the transformation of angles in trigonometry. Fine. The formula says sin c minus sin d is nothing but 2 cos c plus d by 2 sin c minus d by 2. 2 cos c plus d by 2 sin c minus d by 2. Now if we consider this is as c and this is as d, then in the next step we get limit h tends to 0, 2 cos c plus d by 2. C means x plus h plus d x by 2 into sine c minus d x plus h minus x by 2 whole divided by h. Okay, c plus d by 2 x plus h plus x by 2 c minus d by 2 x plus h minus x by 2, which is equal to limit h tends to 0 2 cos x plus x 2x plus h by 2 sine, the x's will get cancelled, so h by 2 whole divided by h. Okay, now we move the 2, we move this 2 in the denominator. Why? 2x plus h by 2 into sine h by 2 upon h by 2. Why we do this? Because there is a very famous formula in limit, that is limit theta tends to 0 sin theta upon theta is equal to 1. So whatever thing that is present in along with sine, if the same thing is present in the denominator, then when the theta is tending to 0, the value of the limit will be 1. So look here, this is h by 2 which is with sine. Here we also have h by 2 which is in the denominator. Basically we are replicating the formula here. Okay, now as h tends to 0, h by 2 will also tend to 0. So now separate as per the algebra of limit. Cos 2x plus h by 2 into limit h tends to 0 sin h by 2 upon h by 2. Okay, now this value along with the limit h tends to 0 is 1, and here we put the value of h as 0 here. Fine. So cos 2x plus 0 by 2, that is cos 2x by 2 into 1, that is cos x. So the differentiation of y equal to sin x is nothing but cos x. This is what we derive it from the first principle. Fine. I hope everything is clear. If this is clear, then we move on to the next problem. Shall I erase this? Shall I erase this? Okay. I'm just erasing the calculation. Differentiate y equal to e to the power x using first principle. This is the second problem. So the first step is same. Let y equal to fx equal to e to the power x. Now we are to calculate dy dx using first principle. So use the formula limit h tends to 0 f of x plus h minus fx by h. Limit h tends to 0. What is f of x plus h? What I have told you earlier. This x is replaced here. Okay. So in the input now it is given x plus h. So e will have a power or exponent as x plus h. Limit e to the power x plus h minus fx is nothing but e to the power x by h. Okay. I hope this is clear. Simple things. Limit h tends to 0. What is this? E to the power x into e to the power h minus e to the power x by h. addition in power. That means these two are in a product form. Now, in the numerator, there are 2 e to the power x. So, take it common. E to the power x. So, the remaining in the first, it is e to the power h, and in the second, it is minus 1 divided by h. Fine? Now, this e to the power x, it has nothing to do with this limit h tends to 0 because there is no h in e to the power x. There is no h in e to the power x. So, make it out of the limit. So, limit h tends to 0, e to the power h minus 1 by h. This is what we have got. Now, this is a very famous limit. This is a formula. Limit anything to the power 0, e to the power anything minus 1 by anything. That means limit x tends to 0, e to the power x minus 1 by x is equal to 1. This thing is being replicated here. This thing is being replicated here. So basically e to the power x into 1, which is nothing but e to the power x. Got it? So basically, in the beginning, we will face some difficulties to solve this type of problems. But if you solve ample examples, exercises, then this will be very easy to you. Okay? So I suggest you go watch this video, understand this, and solve a lot of problems from the textbook that you are following right now. I hope you enjoyed the video. If you enjoy it, please like and subscribe our channel. Thank you.